In note 6.4, we've been working towards the ability to graph general sine and cosine functions, something like y equals a times the sine of bx minus c plus d, or a similar form regarding cosine. So when we're doing this analysis, we know that a, the absolute value of a, is the amplitude of the function, and it's always positive. That's why we take the absolute value of a. C over B, where does that come from? If we have both a horizontal dilation, so B is something other than 1, and a horizontal shift, we need to factor out B, the coefficient of x, in order to get the proper horizontal translation, which is sometimes called a phase shift. So we're going to rewrite these functions as a times sine, factor out the B, so we'd have x minus c over b plus d, and in terms of cosine, we would have a times cosine, factoring out b. We'd have the quantity b times x minus c over b plus d. So now we can see that the phase shift, c over b, comes from this factored out version. D is the vertical shift, and 2 pi over b is the period, which the period will change if we have a horizontal dilation. And then here's a general note, which we did up above, that if there's both a change of period, so that's a horizontal dilation, and a shift, it's helpful to factor out b and rewrite the equation in this form. Let's go ahead and analyze one more example. We're going to look at the graph, transformations in the graph of f of x equals negative 3 sine the quantity 2x plus 3 pi minus 5. The first thing that we'd like to do here is make sure that we factor out the value for b, because we have both a horizontal dilation, a change in the period, and a horizontal shift. So I'm going to factor out the 2, leaving us with x plus 3 pi over 2 minus 5. And I want to do that first so that I don't forget as I go through my analysis and then make a mistake. The amplitude comes from the negative 3 out in front. So the amplitude is the absolute value of negative 3, which is 3. The period of a sine or cosine function is always 2 pi over b. B in this case is 2, so it's 2 pi over 2, which is pi. Reflections are going to come if we have a negative outside the function, which will be a reflection. In this case, we have a reflection in the x-axis because we're multiplying values, y values by negative 1. We don't have a reflection over the y-axis because we don't have a negative factor. Actually, that's probably the wrong place to put it. B is positive. If b were negative, then we would have a reflection over the y-axis. Translations, we have in terms of horizontal, this plus 3 pi over 2 means the graph is translated left 3 pi over 2, and this minus 5 means it's translated down 5.